Hey everybody, so welcome to day 2 of the position, velocity, and acceleration. So before we gave you guys equations and we asked you to kind of analyze them in terms of position, velocity, acceleration, speed, moving left and right, all that kind of stuff. So now we want to know how can we do this from a graph instead. So here is a graph of Waldo's velocity. So Waldo's pacing back and forth along the x-axis. This is his velocity. He's pondering his clothing choices, his math knowledge, and his ability to blend into a crowd. So we're going to answer all of these questions that pertain to Waldo, okay? So let's see, instantaneous velocity. Well, we're given the graph of velocity. So all I have to do to find an instantaneous velocity is look at the y values. It's nothing special here because we were given the velocity function. So if I want Waldo's velocity at t equals 14, that just means what's the function value at 14. So if I go over to 14, I can go up and I can see that he has a velocity of 3 feet per second. Let's talk about how to figure out how we know when Waldo is moving to the right. So anytime we want to talk about a particle moving to the right, Waldo's going to be the same thing, just means that the velocity is greater than or equal to 0. So since we're given a graph of velocity, that means if I want to know when it's positive, I want to know where is it above the x-axis. So let's see, Waldo's moving to the right when it's above the x-axis, so from 0 to 3. And then again from 9 all the way to 19. Excuse me. All right, let's talk about moving to the left then. So if we want to know when Waldo's moving to the left, it means we're going to be looking for when the velocity is negative or less than or equal to 0. So in other words, when are we below the x-axis? So his velocity is below the x-axis from 3 to 9. Oops, 3 to 9. And then again from 19 to 20. Now, in terms of speed, we have to not really do too much more. The speed really just means we're looking at the absolute value of the velocity, and we're given the graph of velocity. So all we have to do is ignore the signs on the velocity function. In other words, we're going to do what we did to find the instantaneous velocity. Look at the y values. And then just take the absolute value. So if I want Waldo's speed at t equals 5, that means I want the absolute value of his velocity at 5. So his velocity at 5 is negative 3. So if I take the absolute value, I get 3 feet per second. Let's talk a little bit about acceleration. We know that acceleration, so a of t, is really just the first derivative of the velocity function. So if we think back to when we first started talking about derivatives, we said that derivatives just mean the slope, right? So if I want to know his acceleration and I'm given the velocity function, I just need to find the slope of the velocity function. Just a couple of quick side notes for you guys. Anytime we say that the slope is positive, in this case, it means that the velocity is increasing. So a positive slope means the velocity is increasing. It means that the acceleration is positive. If we say that the slope is negative, or if we can see that the slope is negative, which really means that the velocity is decreasing, then we can say that the acceleration is negative. So positive slope means acceleration is positive, negative slope means acceleration is negative. But really what I want to get at here is that if it's a positive slope on the velocity graph, then it means the velocity is increasing. So that's an important distinction that we're going to make throughout this unit. So what is Waldo's, wow, I can't speak. What is Waldo's acceleration at t equals 1? So his acceleration at 1 just means find the slope at 1. So if we go to 1 here, we can see that this is a constant slope of -1. So his acceleration is -1 feet per second squared. All right, in terms of speed increasing and decreasing, in order to figure out when when the speed, is increasing or decreasing, we need to look at the acceleration. So we need to look at a of t and v of t for the speed increasing and decreasing. You have to compare the signs of the acceleration and the velocity functions. So if the velocity function and acceleration function have the same sign, then we say that the speed is increasing. So really what that means is if the velocity is positive and the acceleration is positive, or if the velocity is negative and the acceleration is negative. Oops, negative, less than 0. So let's see if we can find this on the graph. Velocity is positive. Well, we said that that means we're looking for above the x-axis. And the acceleration is positive. That means we're looking for a positive slope. So anything that's above the x-axis and has a positive slope. So that would be right here. So definitely from 9 to 12, his speed is increasing. But we have to remember that it could also be when the velocity and acceleration are both negative. So if we're looking for the velocity to be negative, that means we're looking for anything below the x-axis, and a negative acceleration means that I want a negative slope. So I want below the x-axis with a negative slope. That would be right here, and again right here. So those are both below the x-axis and have a negative slope. So let's see, that's from 3 to 4. So I'm going to put that first because I like to always put my stuff in order. So from 3 to 4, and then again from 19 to 20. All right, so let's talk about speed decreasing then. So we're going to be looking for any place that the velocity and acceleration have opposite signs. So in other words, the velocity could be positive and the acceleration negative. Or we could have the velocity be negative and the acceleration be positive. So a positive velocity means I want to be above the x-axis. A negative acceleration means I want to have a negative slope. So above the x-axis, but going downhill. So above the x-axis, but a negative slope would be here, here, and here. So we've got 3 separate intervals there where that works. So that would be from 0 to 3. It would be again from, let's see, 15 to 17. And then from 18 to 19. But that's only the first part, right? We also need to look and see, is there any place that the velocity is negative and the acceleration is positive? So we're looking for anything that is below the x-axis and has a positive slope. So below the x-axis and a positive slope is right here. That's going to be from 6 to 9. Now I knew that that was coming, so I left some space. If all you do is list them for right now, you guys, that's fine also. All right, we're going to do one example together, and then we're going to save the last one to do together in class. So the accompanying figure shows the velocity of a particle, moving along a coordinate line. So we want to know, when does the particle move forward? If we're looking for the particle to move forward, it means that we want the velocity to be greater than or equal to 0. So anything that's above the x-axis. So that means the particle moves forward on the interval from 0 to 30. 0 to 30, because the velocity is greater than or equal to 0. So anything above the x-axis we were able to go with. Then let's talk about moving backwards. So if I want to move backwards, it means I want the velocity to be negative. So I'm not going to rewrite all of this, but the particle is going to move backwards on the interval, let's see, anything below the x-axis. So from 30 to 55, because the velocity is negative, so less than or equal to 0. So I'm going to take some shortcuts here just so we can try and make the video a little bit shorter for you guys. Alright, speeding up, so let's see. We just talked about how if we want to know when something is speeding up, we need the velocity and acceleration to have the same sign. So let's see, the particle is going to speed up. Speeds up, there we go. Velocity and acceleration have the same sign, so we either want to be above the x-axis and positive slope, or we want to be below the x-axis with a negative slope. So those two intervals right there. So let's see, we're going to speed up from 0 to 10, and from 30 to 40, because the velocity and acceleration have the same sign. Alright, let's see. Then if we want to talk about when the particle slows down, we want the velocity and acceleration to have opposite signs. So the particle slows down let's see, we want to be either above the x-axis with a negative slope or below the x-axis with a positive slope. So we're slowing down from, let's see, what is that? Is that 15? Yeah, 15 to 30. And again from 40 to 55. Oops. 40 to 55, because velocity and acceleration have opposite signs. I know this is not the neatest and the most organized I've ever made a video, you guys, so I apologize. All right, so now we want to look at when is the particle's acceleration positive, negative, or zero. So just as a quick reminder, we know that if we're looking for the particle's acceleration, we're going to be looking at the slope. So if I want to know when the acceleration is positive, then I need to know where do I have a positive slope. So we're going to have a positive slope from 0 to 10. And we have a positive slope from 40 to 55. Because the velocity is increasing. Or in other words, the velocity has a positive slope. All right, then let's look at where the acceleration would be negative. So the acceleration is going to be negative any place that there's a negative slope. So that's going to be from 15 to 40. And that's because the velocity is decreasing. Or we could say that the velocity has a negative slope. And then let's see. Now we want to do where is it 0. So if I want to know when the velocity is 0, it means that I want it to not be changing, right? So I want to know where is it constant. So where the slope is 0, excuse me. So if I want that, that's going to be from 10 to 15. So the acceleration is 0 on the interval from 10 to 15 because velocity is constant. All right. When does the particle move at its greatest speed? So we know that speed really means the absolute value of velocity. So if we give you a velocity graph and we're asking you for the greatest speed, you really just need to look at the minimum and the maximum and just pick the bigger one regardless of the sign. So when we look at this graph, we can see that the minimum down here would be negative 40. The maximum would be 60. So really we're comparing 40 and 60. So the particle moves at its greatest speed when it's up here at 60. And so that's going to be from 10 to 15. And we can just kind of say that this speed is 60. Oops, you can't see that. Sorry. Okay. When does the particle reverse directions? Well, if we want to say that it's reversing directions, we're saying that the velocity is changing from positive to negative. So really we want to know, when does the velocity function cross the x-axis? Because that's going to mean that it changes from positive to negative or negative to positive. So let's see, the only place that that happens is right there at 30. When approximately is the particle moving at a constant speed? So we talked about that actually up here when we said that the acceleration was 0. We said it was 0 because the velocity was constant. So we're going to be looking at the particle to be moving at a constant speed from 10 to 15. And again, we know that simply because the slope here of the tangent line would be 0. or the slope of the line, excuse me, even just in general, would be 0. So that means it's moving at a constant speed. All right, I know that was a lot of information. I know this is a little bit of a longer video, so thank you for bearing with me. If you have any questions, please make sure you wrote them down. We are going to go over any questions that you guys have, and we'll do one more example together before you dive into some practice on your own. Thanks for watching. I'll see you in class.